The thing that's exciting about this is that you all have different organisms that you're working with, not just horses. So we're going to start off looking a little more in depth at horses, but the basis of everything that I do is thinking about how animals fit into an ecosystem. I feel very strongly that we have to look to the sort of natural niche of an animal in order to effectively meet all of their needs. And so we've got our grasses. Right now we're talking about horses as our herbivores. Basically, we play the role of a carnivore in a grazing system, right? So a carnivore moves an herbivore around on the landscape by threatening to eat them. We tend to use fences, but that's sort of the role that we play. And then I always like to not forget the detritivores, all those organisms that are in the soils and that are making nutrients available to our animals in the grazing system. So we're going to look a little bit at each of these, but we're going to spend the most time on the horse. And this is, I don't know whether I should play this or not, but I do love David Attenborough, so we'll see if we have time and we'll come back to that. It's just a great little clip that talks about sort of the role of the herbivore in grazing systems. But basically we're gonna jump right into who's our herbivore? What makes a horse, or any other organism, what they are in the grazing system? So we're gonna look at physical aspects of the animal, things like eye placement, their musculoskeletal system, how they get around, what they get around on, how they eat and digest, but then also behavioral and other considerations. So are they a gregarious animal? Do they like to be with others of their species? What are their reproductive cycles? That gets more important if you're looking at a breeding operation, or if you have dairy cows or something else that's producing really intensely in certain parts of their cycle and not in other cycles or other parts. What are their defense mechanisms, their behavior and learning styles? And then there are sort of the individual considerations. What are you doing with those animals? When do you need access to them? How do you make that happen? And then never forgetting that we're all humans with only a certain amount of time. So you'll see some examples here, and I tried to make these all really realistic for the average person, not for the person who has limitless funds to sort of create a system. Those can be really great, but I think most of us work with different, what are those called? Limitations, budgets, yes, those too. So I want to be realistic. So here's our horse. You can see the inside and the outside. Horses are sort of the epitome of an herbivore. They are a prey species that uses movement as their primary defense mechanism. So this is a flight animal, and there are lots of things about horses that tell you this, right? So if we go back to that video, one of the things he talks about is that herbivores run on their tiptoes, right? Horses have evolved so they run on the tip of only one toe. So as they've evolved, this is actually a toe here. And you'll see the remnants of their other toes in the chestnut on their legs. So these are very much a running animal. They have musculature that's bunched at the tops of their legs. They're really very delicate in their legs themselves, so they can get around very quickly and easily. And they have eye placement that tells you that they are prey, right? Their eyes are on the sides of their heads. They can see very well all around them, not so well directly in front of them, not so well directly behind them. But, and they also have vision that's evolved to see movement, right? So they're supposed to be grazing. That's what they do. They stand with their heads down, they keep track of what's going on all around them, and if something moves or scares them, they run. All right? So those are all things that you want to be able to fit into a system of management if you want this organism to be a happy organism. So a lot of what I see when I go out to farms and talk to people about grazing horses is they say, well, I can't restrict their movement. I can't put them with other animals or other horses. They need to have certain types of feed. So these are all things that restrict how you can manage them. So we're going to go ahead and talk a little more about that. The first thing I'll say about horses is that they are really hard to graze well. I have done it and struggled with it. I've done it well, I've done it poorly, I've made huge messes. I've come up with some solutions that work for some situations, but it is going to vary according to most of your systems. So one thing that differs in a horse from a ruminant, they have two sets of teeth, right, in the front. So when they bite grass all the way to ground level if they want to or if they can. So two sets of teeth. They're very efficient at chewing. And all of this tooth area and also these giant masseter muscles or temporal muscles, that come down the sides of the face are going to be acting to grind feed into digestible pieces. We already talked about hooves. But another thing that I'll mention while we're here is that horses are also prone, if they're fed incorrectly, to metabolic disorders that can affect their hoof structure. Cows are also prone to this, but in horses, because what we are depending on a horse to do is to move for us, this is really important that you feed them in a way that's not going to encourage laminitis or founder in your horse. All right, so equine digestion begins here with those teeth that are really effective at biting off grasses. So one of the things that horses can do that a ruminant can't is that they can eat really tough, stemmy forage. And this is not usually what people think of with feeding horses, right? Often you talk to someone and they'll say, oh, I want my horse to eat alfalfa, and I want my horse to eat timothy, and I want my horse to have second cut hay, and I want them to have beautiful sort of lawn-like pastures. Those are all sort of counter to what the digestive tract tells us about horses. So when they graze, if you give them grass that's this short and is very high in energy and very high in protein, they're very capable of eating it. But if you give them grass that's this high and is very stemmy and has lots of lignin and cellulose and the energy is bound up in fiber, they can also eat that. Whereas a cow is going to struggle to eat enough of that forage to provide the nutrients that they need, and also just to physically remove that forage from the ground. So when a horse grazes, they bite. When a cow grazes, they stick out their tongue and they wrap it around forage and they rip it off. And they use their lower teeth to kind of pull up and cut through that forage. And that palate that they have on the top of their mouth, if you feed them really stemmy forage, it's going to actually cut that fleshy palate at a certain point, which makes it very uncomfortable, right, to eat, and sort of like pulling dental floss across your gums. And so you'll actually discourage intake just through discomfort. Horses can eat that stuff all day. And in a sort of plains ecosystem, the zebra is the animal that will survive the longest in a drought situation because they're able to eat that long, stemmy, dry, what we basically crappy forage. So the way that they do that has to do with the rest of their digestive tract. So they begin with their forage going into the stomach. It's an acid-based digestion, which is basically just breaking down that feed into more accessible particles and also activating enzymes which will allow that feed to digest as it moves through the digestive tract. The small intestine, which is curled up in here, is about 70 feet long. So it's a huge distance, small volume. So if you think about that as sort of a water pipe of sorts, when you put a large volume of feed through that and you put it into a narrow pipe, what happens? How does it move? It could potentially get plugged, but if they've done a good job chewing, it shouldn't. Does it, compared to a big wide pipe, it's going to move really fast in a narrow pipe and much slower in a big wide pipe, right? So the passage through the small intestine is only 2 to 3 hours. And the small intestine is where that animal is absorbing a lot of the nutrients that they've taken in. So they're going to be taking up protein, carbohydrates, which are especially important, and also a lot of vitamins and minerals in that section of their digestion. What happens if they have an excess of carbohydrates in their ration? So basically sugars. Stuff is moving through that small intestine so fast that the sugar can't be absorbed quickly enough to take it out of their digestion and get it into their body. And so it's very similar to the situation in a cow when you feed too much grain. You're basically putting too much sugar into a fermentation vat. And so the hindgut, which is the small colon, the large colon, and the cecum, are all populated by microorganisms that help horses to be able to break down forages. So up until this point, hold on a second, let me grab my plug for my computer. There we go. So there's an outlet. So up until this point, the horse has not digested any of the cellulose material. Up until this point, the horse's digestion is basically like ours, right? It's monogastric. It's based on an acid and enzyme digestion. And we can't eat hay, as we know. So the hindgut is all about breaking down that other material. If passage through here is so fast that all of the sugars in the ration are not absorbed, they go into the hindgut, and you can imagine it's sort of like, how many of you have made hard cider or kombucha? What happens when you put some sugar into that jar? Lots of fizzing, right? So your microorganisms are reacting really quickly. They're creating gas. They're also creating alcohol and acid. So if that happens in your hindgut, then not only can it cause digestive upset, it also can change the population of microorganisms that you have in your hindgut, which can result in a die-off of other organisms, release of lactic acid, and can end with founder. So that lactic acid can release toxins into the bloodstream that then shut down the movement of blood in the hoof and cause the coffin bone to rotate down through the bottom of the hoof, which is really uncomfortable and especially bad for an animal that you want to move around. So what we want to feed this animal is something that's going to give them adequate nutrition without giving them too much sugar and plenty of fiber so that that hindgut can do what it's built to do, which is to hold a large volume of feed over a long period of time. So generally hindgut fermentation is 2 to 3 days. This section is 2 to 3 hours. So we want to give that horse what it needs digestively. And let's see, maybe I'll go over and draw you a little graph. And some of you may be coming with a lot of grazing background, and this is not telling you what you need to know, but basically when grass grows, dry matter goes like this, right? So it starts off growing slowly, grows much more quickly, and then eventually can actually senesce or die back, and dry matter can decrease. Protein generally starts out higher and gets lower, and energy also starts out higher and gets lower. So this is soluble energy, whereas fiber starts out low and gets higher over time. So basically what's happening is the energy is starting off in a soluble sugar form and then being translated into a fibrous form as your grass gets taller. So where do you want to feed your horse that grass? When it's taller, right. So here's a picture of a horse grazing some nice tall forage. And these are all open access photos that I found on Wikimedia this morning, so forgot to post the reference there. But these are some other things to think about in our grazing system as well. So horses like to be in groups. They have a complex social order. Most of their communication is through gesture. So you can see the horse on the right there is sending some messages to its two buddies there. The two on the, my left, your right, sorry. The two on my left have relaxed ears. They're just eating. The one to this end, it has its ears back and is sort of saying, my feed, back off. So thinking about how horses send messages to one another and how they interact in a group can be really important. And the point of this picture is not that horses fight a lot. The point is that they're very nimble and they like to move a whole lot. And as an organism, that movement and that type of ability to defend themselves or to just get out of the way of predators was really vital to their survival. And so I think that in a grazing system you have to allow for this. And this of course is going to vary quite a lot. If you have a 23-year-old Belgian, that animal is not going to need nearly as much energy and movement as a 3-year-old thoroughbred or Arab or something. So this is variable, but horses need us to think about how they can meet those behavioral and sort of social needs without causing destruction to our farm and facilities. All right. So then we get to how do we create a horse grazing system. And let's see, so what I like to look at with the organisms that I'm grazing is what are the upsides of the horse's impact or of the animal's impact. So what can you guys think of that is an upside of horses on pasture?
Well, them being able to eat the grass when it's high is definitely advantageous, because at that point it's no longer good for most other animals.
Right.
If you're on rotational grazing and it's gotten catch up and you don't want to mow, that's definitely a good option that you're actually giving something healthy to the animal rather than putting something out there,
Absolutely.
cow or a sheep, it's not really healthy for them to be doing that.
Yep. Yeah, that's a huge one. What else? Any other thoughts that you guys have?
Free fertilizer, and it's being spread.
Right, so like every grazer, what goes in, about 90% of it comes out again, and they're great at moving that around on the pastures, as long as you're moving them. Yep. Yep.
That's basically what we do with dairy cows.
Right.
We put them on, and after every milking, we put them on a new section of pasture, so they're rotating around, getting their own feed, and spreading fertilizer.
Yep. Oh, it's a good thing. Anything else that you guys can think of? Yeah. Yeah. So biodiversity is great. Parasites, by their nature, are really, really host specific. So cow parasites are mostly not goat and sheep parasites, or mostly not horse parasites, or mostly, pretty much definitely not human parasites. So there's a lot of misunderstanding about that, like, oh, my chickens have mites, my horses are going to get mites. No, they're not. But the upside of that is that you can really decrease parasite load on pasture by mixing species.
Horses eating low enough to eat another animal's parasites, isn't that too low?
It depends. So yeah, it could be.
Grass and too low for the animal.
Right, yeah, it could be, although those parasites are evolved to, if there's a wet period, they're going to climb up the forage. And you can certainly have an overlap of those zones where your grazers are grazing down and your parasites are climbing up. But you're definitely right to an extent. You don't want to be pushing animals to eat to the soil surface, because they're going to not only destroy your pastures, but also pick up a lot of parasites. However, if, for example, you're trying to decrease sheep parasites on your pasture, horses can actually ingest, digest, and kill sheep parasites. So I suppose in that sense you might push your horses to eat low in a pasture to decrease the parasite load. The principle of parasite management, there are specific tools like that, but there also is just the fact that if you have, say, 10 acres, well, let's say we have two 10-acre blocks. If you put only sheep in here, right, and your total load on that is 6,000 pounds of animal weight. The parasite density for sheep parasites is going to be much higher than if you have 6,000 pounds of weight on that 10 acres and you have some sheep and 2 horses. Right, so you're decreasing the relative density of one type of livestock on a piece of land. And this does not have to be, it doesn't mean you turn all your sheep out in one pasture for 3 weeks and you put